All right, Fascia Friday, episode 4. This week we're going to take a look at the British Journal of Sports Medicine Fascia consensus statement. So this is really just going to kind of be a very broad descriptive analysis of what fascia is and kind of how it's influenced in performance and function and movement and so forth. And these research reviews are something that I want to throw in, throughout this series, and I think it's important to also understand the technical aspects of this as well. So with that, the full description, or I'm sorry, the full citation can be found right here. But for this one, really what they were looking at is to provide just an overview of the current state of knowledge within the fascial system, ranging between physical therapy, body work. They don't necessarily look at this from a strength and conditioning lens, but performance being somewhat included here. Summarizing the responses of fascia to different loading patterns and stimulus types, how it responds to injury, the process of aging, and then outlining some methods for how we study fascia and how this is researched and investigated. And then to kind of just highlight some of the contemporary views or how we're now understanding this biological system now that we have more advanced technology and applications to be able to study it. All right, so if we start out here by taking a look at the structure, and this column here is going to be tied to these images down here below. But the researchers of this study described fascia to be a three-dimensional continuum of collagenous, fibrous connective tissue. And even though that may seem like a mouthful, that's actually a relatively brief synopsis of describing what fascial tissue is. But I actually want to reference Mike Boyle, who put out a video this week talking about how he describes the fascial system to his athletes and coaches. And he says, he tells people to think about a plastic bag with a frozen chicken breast inside, and the fascia is the plastic that envelops the frozen chicken breast. And I think that this is a really novel way of looking at the tissue. However, I would actually add one step to that, and I would say that you want to think about that frozen bag of chicken, but you want to also consider what that substance looks like when the chicken has actually started to thaw out, and we start to get that filmy, semi-liquid, semi-non-liquid substance that starts to fill the bag as well. And I think that is actually a very, very solid and complete way of perceiving the fascial system, because this is something that permeates every aspect of our biology, right? It's not just the encasing around the muscles, but it actually is also permeating down to really a cellular level, but wrapping in between fascicles and in between muscle spindles and so on and so forth. But this is really like a never-ending system. And here in the first picture, we kind of see the ones that we're most, or we have the picture that we're most familiar with, which is this kind of continuum, network of fibers that encase muscles and bones and such. But if we move our way down over here to the third image, this is showing more of that gel viscous type of substance or property of fascia that we see down at like a granular level. So when we say that everything is connected, that's not just a figure of speech. This really is a totally integrated system that has a ton of ramification. Now, if we move over to the force aspect and fascia's involvement in force, I want to start out with saying that I look at force really in three distinct or particular ways, and that is force transmission, or more commonly referred to as transfer, force summation or expression, and then force dispersion or acceptance. And again, the fascial system is going to be critical in all three aspects of this. But if we look to the intra and extramuscular fascial tissue, these tissues are contributing to mechanical production, mostly through the force summation, where the fascial tissue that is enveloping and within the muscle belly and the muscle fibers is helping to create a full and complete contraction. And then to speak to the injury portion of this, there's a very strong biochemical response or interaction with the fascial system, which, to be perfectly frank, is something that you probably don't want to hear or learn from me. But the gist of it is that when we have a presence of inflammation, there's a pro-inflammatory response within the fascial tissue. And because of the pH change and because of the biochemistry that is occurring, the receptors are then activated, and these receptors are known as nociceptors or nociception, which are pain receptors. So we can say now that the fascial tissue, at the very least, has a sensory role or responsibility with regard to injury and return to play. Beyond that, we can look at, again, the compression and the tension factors, where if we have overly compressed fascia due to calcification or collagen development, from an injury site, such as an ankle sprain or coming off of an ACL for a knee, the surrounding fascia can then become compressed because the site has been immobilized and there's been a change in the muscular tendinous relationship. So that's going to affect the surrounding fascia. This can create things like nerve entrapment. Another one that I didn't list, but to consider, is circulation impairments. And then we go back to the sensory aspect of it. Does it impair or dampen or amplify the pain receptors? So this is where manual therapy can be of tremendous help and kind of helping to restore the glide of the fascia and then help with the sensory balance. All in all, this is a very wide-reaching system. This is a very, very impactful tissue. And I think, I can't overstate it enough that just because we're now emphasizing or understanding the fascial system, it does not negate what we do know about the musculotendinous and the musculoskeletal systems. This is just something in addition to that. But it certainly does have some involvement or some significant involvement perhaps in both force expression and also injury management or injury inflammation timelines. So we need to pay attention, if nowhere else, at least in those two areas.